Welcome back to the deep dive. Today, we're pulling back the curtain on proofing.
Yeah, it's something most people don't think about. Think about it. Whenever you see like perfect packaging color or a really sharp magazine photo, there's a whole process behind that ensuring accuracy. And when it goes wrong, it gets very expensive very fast and frustrating.
Absolutely. We start with the basics, what is a contract proof, but then we zoom right into the technical stuff, like why one type of proof gives you way more certainty than others, especially for those really critical print jobs.
So our mission here really is to unpack this for you. We want you to get a clear handle on contract proofs, the big difference between halftone and contone. Those are the two main types, and, crucially, why picking the right one isn't just technical nitpicking, it's about getting reliable results.
It might sound a bit techy, yeah, but there's a fascinating story here about how print quality is actually guaranteed, preventing those expensive headaches.
Definitely worth understanding.
Okay, let's jump in. So first things first, what exactly is a contract proof?
It's a color-accurate pre-press print.
Color-accurate pre-press.
Okay, but the key is in the name, contract. That tells you it's a real job. It's not just like a quick look-see. It acts as a binding agreement.
A binding agreement. Between who?
Between the client, you, and the printer.
Ah, okay. So it's serious.
Very. Both sides use this specific approved proof as the reference standard. It's the benchmark for everything. Color, content, layout, overall quality. Everyone agrees this is what the final job must match.
Right, so it stops arguments later about whether it looks right or not.
Exactly. Removes the subjectivity.
Got it. So this is the gold standard print everyone signs off on. How's it actually made? It's not done on the final printing press itself, is it?
No, definitely not. It's usually printed on a high-quality inkjet printer. And crucially, this happens before the main job goes anywhere near the big conventional press.
So it's a checkpoint.
A vital checkpoint. Before you commit all that time, money, making plates, setting up the press, this is where you catch things.
Okay, makes sense. So we have this approved inkjet print, this contract. Now, there are two main flavors, halftone and contone. What's the basic difference?
A contone proof shows smooth, seamless color transitions. Think of a high-quality photo print. You don't see dots, just smooth color.
Right, like a photograph from a good printer, smooth blends.
Precisely. Now, halftone proof is different. It shows the image using screen dots, tiny dots.
Screen dot.
Yes, it directly mimics how a traditional printing press works.
Yeah.
If you look really close at a newspaper photo, or even a magazine image sometimes.
Yeah, you can see the little dots, especially with a magnifying glass.
Exactly. Those patterns of cyan, magenta, yellow, black dots. A halftone proof simulates that specific dot structure.
So one is smooth photo style, the other shows the actual dot pattern the big press will eventually use. But they both need to be color accurate, right?
Oh, absolutely. Color accuracy is table stakes for any contract proof. That's non-negotiable. The difference is really whether showing that specific dot structure and how those dots build the image and affect the look is also critical for your specific job.
Okay, which leads to the obvious question, why have two types? Why not just stick to one?
Well, they serve different needs, really. It all depends on how important that dot structure and its potential side effects are for the final printed piece.
Side effects.
Yeah, things we'll get into. But if you're printing something, say, fairly simple, where seeing dots doesn't matter, maybe contone proof is perfectly fine. But for those high-stakes jobs, high-end brochures, packaging, art books, where every tiny detail matters, then seeing the dots becomes crucial.
Let's dig into that. Tell us more about contone first. When are they the right choice?
So contone proofs, they simulate the image using that continuous tone output. Tonal shifts are smooth, no visible screen pattern. Their main job is really to let you check the overall color appearance, make sure all the text and images are correct, and just confirm the layout, the positioning is right.
So like if I was printing a straightforward flyer, or maybe a poster that people see from a distance where I mainly care that the colors are right and the text is readable.
Exactly. For general contract proofing, where the nitty-gritty of the dot structure isn't something the client needs to sign off on or worry about, contone often does the job just fine.
Okay. Now, let's talk halftone proofs. This sounds like where things get really precise.
They really do. A halftone proof is engineered to simulate the final printed piece by using the actual screening pattern, the exact pattern the conventional press will use later.
Wow.
Its whole purpose is to replicate the dot structure and the overall visual appearance of the job exactly as it will print.
Replicating the dot structure on an inkjet proof. How on earth do they manage that level of precision? That sounds tricky.
Well, this is where the key technology comes in. A true halftone proof achieves this by using the very same digital information, the exact data file that gets sent to the plate setter or film setter. The machine that makes the physical printing plates for the press.
Hold on. The same digital blueprint that creates the final printing plates is used to make the proof.
Precisely. Not a simulation based on the design file, but the actual output file going to the plate.
Okay, that explains the precision.
And that's why these proofs are absolutely essential when things affected by the dots are critical. Things like potential moire patterns.
Right, you mentioned those weird distracting wavy patterns.
Yeah, they can pop up unexpectedly when different screen angles clash in the print. A halftone proof can reveal if that's going to be a problem. This level of detail is vital for, high-end stuff. Luxury packaging, fine art reproductions, complex magazines, anywhere tied to the dot structure is absolutely paramount.
That makes total sense for anything where quality is the top priority. Now, I've heard other terms thrown around: screen proofs, dot proofs. Are they basically the same thing as halftone proofs?
Yeah, you might hear screen proofs, dot proofs, even one-bit proofs. But halftone proof is probably the most common and widely understood term for a proof that specifically aims to show the screening structure used in the final print run.
Okay, good to know. So how do printers actually make these super accurate halftone proofs? Using that exact data from the plate making process.
Fiery has a key technology for this. It's called Fiery XF, and specifically an add-on called the one-bit option.
Fiery XF with the one-bit option. And what's the main idea behind how their system works?
It's built around a concept they call RIP once output many. The Fiery one-bit option takes the exact screen data, the very same data file that's already been processed and is heading towards the film setter or plate setter.
And then the Fiery system with this one-bit option takes that specific finalized file and uses it to drive the proofing printer.
Correct. No recalculation, no reinterpretation. And that is what guarantees that the halftone proof have the identical screen structure as the planned production run.
Identical structure, meaning?
Meaning the screen dot shape is the same, the angle the dots are laid down is the same, the screen ruling, that's how many lines of dots per inch, is the same, and the actual screen dot size is the same.
Wow, okay. That level of fidelity sounds incredibly powerful. It really closes the loop. So what are the big advantages, the benefits you get from that level of accuracy using this one-bit approach?
Well, the main thing is an extremely high degree of security, predictability. For those really critical, high-value print jobs, everyone at the production team, the client needs absolute confidence that the final printed product will match the proof they signed off on.
Right.
Only a halftone proof generated using this method from the actual one-bit data can offer that level of security.
Why is that level of certainty so vital in printing?
Because think about it. The proof becomes essentially an exact replica of what's going to be exposed onto the printing plate or film, which means you can spot potential errors really early in the game.
Before you've spent the big money.
Exactly. Before you've made expensive plates, before you've used up valuable time on the printing press. Those are the costly stages you want to avoid mistakes in.
What kinds of errors can you catch at this proof stage that you might otherwise miss until it's too late?
Well, you can reliably detect those potential mores we talked about. You can catch other weird visual artifacts or glitches caused by the screening process itself.
Things you wouldn't see on a Contone proof.
You can also verify trapping. That's how colors overlap slightly to avoid white gaps if the press registration isn't perfect. And of course, you're still checking for overall color accuracy and any basic content errors, like typos or missing images.
So it catches the problems that are specifically linked to the mechanics, the physics, of how those tiny dots are going to behave on the page.
Precisely. It's validating the actual physical printing characteristics. And the knock-on effect for customer satisfaction is huge. It gives the client total confidence. What I approved is exactly what I'm going to get.
Reduces those awkward conversations after the job is printed.
Dramatically.
Yeah.
Fewer stressful debates about quality, fewer requests for reprints or discounts. It just builds trust.
Fewer headaches, happier clients. Makes sense. What about the benefits for the print provider, the production side?
Oh, they're significant too. By catching errors this early, you prevent expensive mistakes downstream in pre-press, where plates are made, and in the press room itself. This saves a lot of time, and it saves materials throughout the entire workflow.
Less waste.
Less waste, absolutely. You use your production capacity, those expensive presses, much more efficiently. You lower your material costs. And all of this adds up pretty quickly to a faster return on investment for the proofing system itself. It's about streamlining the whole operation and just avoiding those costly do-overs.
That really connects the technical detail to the real-world business impact. Okay, our sources also mentioned some specific technical points about this one-bit option. Anything stand out there?
Yeah, a few things. Software-wise, it needs Fiery XF version 8.0.5 or newer. And importantly, it's built to handle all the common industry-standard one-bit file formats, different types of TIFF files, PCX, Harlequin page buffer, the common stuff.
That's good. Handles the standard formats. Okay, let's quickly walk through the workflow just to visualize how the data moves, because I think that really clarifies it. You start with a design file, right?
Yeah, the artwork file comes into the prepress department. From there, it gets sent to the CDP or CTFP, that's computer to plate or computer to film, your main production software. That's what figures out the final dot pattern. That one-bit file holding the exact digital map of the screened image for the plate. That specific file is then fed into the Fiery XF system that has the one-bit option enabled.
And that Fiery system drives the inkjet proofing printer.
Exactly. The proof will then prints the physical halftone proof. And because it's using that identical one-bit data that was heading to the plates, the resulting proof is, 1, highly color accurate, and 2, crucially, it has the green structure.
Got it.
So you can use that single proof for both the critical color sign-off and for checking all those screen-dependent things moire.gain before you commit to running the job on the press. It's like the ultimate pre-flight check, but specifically for the screened elements of the job.
Okay. So let's bring this all back to you, the listener. We've covered the basics, we've dived into the tech, we've walked the workflow. What's the big so what? Why does understanding contract proofs, and especially these super precise halftone ones using original one-bit data, really matter?
Well, if you're involved with print in any capacity, whether you're designing for it, buying it, or actually producing it, just understanding that a contract proof is your fundamental agreement on quality is, well, fundamental.
It's the benchmark. And recognizing that unique level of security and accuracy you get from halftone proofs made from the actual production data, that's pretty much non-negotiable for jobs where precision is absolutely key, right?
It really is. It's the critical step that just removes the guesswork. It prevents those awful last-minute budget-blowing surprises when the job comes off the press. It's all about saving time, cutting down waste, and just ensuring that what you approved is exactly what gets delivered. It's kind of the unseen engine driving reliability and high-quality printing.
This deep dive has definitely shown a light on how contract proofs act as that vital bridge, that link between the digital design idea and the physical printed reality. And we've really seen that for jobs where every dot matters. The precision you get from halftone proofs, especially when they're powered by tech like Fiery's one-bit option, using that final ripped data, is truly the gold standard.
Yeah, every dot counts, and this lets you see it accurately beforehand. It just underscores the meticulous level of detail needed to get predictable results in, let's face it, a complex manufacturing process like printing. Something to ponder.
Indeed. And that's our deep dive for today.